In this video, I'm going to show you how to multiply numbers that are written in scientific notation. Essentially, what I've got here is four numbers multiplied together. 3.2 times 10 to the power of 4 times 2.0 times 10 to the power of 3. As you may remember, if I've got things multiplied together, I can actually multiply them in any order. 3 times 4 times 2, 3 times 4 is 12, times 2 is 24. Or if I did the 4 times 2 first, I'd get 8, times that by 3, I'd get 24. So it doesn't really matter what order you multiply things together if they're all being multiplied. So what I'm going to do is I'm going to get the numbers 3.2 and 2.0 and multiply them together. And I'm going to get the tens with the powers and then multiply them together. Now, what I'm going to do is I'm going to multiply each of those separately, and then in the end I will have a number that's written as scientific notation. So 3.2 times 2 is 6.4, and 10 to the power of 4 times 10 to the power of 3. What do I do if the bases are the same and I'm multiplying together? I need to add together the powers, don't I? So that's going to be times 10 to the power of 7. Okay, so that's pretty straightforward. The rules are when you're multiplying them together, multiply the numbers out the front and then multiply the index and get your answer. Sometimes there's one further step you need to do. I'll show you another one. If I had 6.8 times 10 to the 7 times 3.0 times 10 to the 4 and I multiply them together, I'd have 6.8 times 3.0 times 10.7 times 10 to the power of 4. 10.7, 10 to the power of 7. So 6.8 times 3, that's going to be 3 6 is 18, 3 8 is 24. Okay, that's going to be 20.4, I hope. And here we've got 10.7, 10 to the power of 7 times 10 to the power of 4. I need to add them together, that's 10 to the power of 11. Okay, well that seems fair enough, doesn't it? I've done the same thing I did before. Do I have this written in scientific notation? No, I don't. Because in scientific notation, the decimal point has to be after the first decimal. That's the rule. That's just keeps everything the same. Otherwise, really we might as well be writing things in pure decimal. Okay, so to move that decimal over there, I'm just going to do one little thing. I'm going to change this part here into its own little piece of scientific notation. So if I wanted to move that over once to here, that'd be saying that that's 2.04 times 10 to the power of 1. And I've still got the times 10 to the power of 11 here as well. Okay, can you see what I've done here? I've moved the decimal place one space over, and I'm changing it from 20.4 to 2.04. Now for those numbers to be equal to the same thing, I would need to multiply 2.04 by 10. 10 to the power of 1 is 10. So 2.04 times 10 is 20.4. I haven't changed what that actually means, it's equal. And I've still got the 10 to the power of 11 there. Maybe you can guess what the next step would be. I've got 10 to the power of 1 and 10 to the power of 11. If I multiply them together, I need to add those powers. So that's going to equal 2.04 times 10 to the power of 12. Okay? Now, of course, these are numbers that are bigger than 1 being multiplied together. You can also multiply numbers that are smaller than 1. So 3.0 times 10 to the negative 2 times, okay, make it an easy one, 1.2 times 10 to the negative 4. If I multiply that together, I get 3.0 times 1.2 times 10 to the negative 2 times 10 to the negative 4. 3.0 times 1.2 is going to be equal to 3.6, and that's going to be multiplied by 10 to the negative 2 times 10 to the negative 4, add those together, negative 4, add negative 2 is negative 6. Okay, so you could have two positive powers, you could have two negative powers, you could have positive and negative. Treat them the same way. When they're multiplied together, you add them. Just be careful with your positives and negatives. In the next video, we'll look at dividing.